Okay, Chapter 5, Problem 29. So during circuit acts, we have this performer that's swinging upside down by their legs. And so their legs, their femur, right? Femur, body, arms, head. All right, I'm not an artist. So their legs, the femur, is experiencing a force that is 3 times her weight, right? 3 times her weight. How much do the bones in the femurs and the upper leg stretch? Okay, so how long are they? 35 centimeters, right? 35 centimeters or 0.35 meters. And what is their radius? If you're looking at a cross section, 1.8 centimeters, right? And her mass is 60 kilograms. Okay, so what we're looking at here is a problem where we're stretching the bone, right? We're stretching the bone. And we've got the force divided by area is Young's modulus, right? Times the change in length divided by, well, change in length divided by the nominal length. By nominal length, I mean the length of the leg or the bone when they are not being stretched. Okay, so what is the area? Well, first, the force. Force is 3 times her weight, right? Which is 3 times 60 kilograms times 9.8 meters per second squared, right? So what is that force? Equals 3 times 60 times 9.8, 1764 newtons. Remember, a kilogram meter per second squared is a newton, so 1764 newtons. All right, what is the area in square meters? What is the area in square meters of her leg? So we've got the radius of 1 is 1.80 centimeters, which is 0.018 meters, right? And the area, if we're going to be, the area is 2 times the area of one bone, because we've got both legs, equals 2 times pi times the radius squared, right? So 2 times pi times 0.018 meters squared. Okay, let's go get that number. Equals 2 times pi, pi is a function in Excel, times 0.018 squared. Okay, 0.00204, or just 0.002 meters squared. Okay, so that's the cross-sectional area we're looking to go into here. Now we need Young's modulus for bone. So we're going to pop over to our book and take a look, and we've got for bone under tension, when it's being pulled like it is here, Young's modulus is 16, right? 16 times 10 to the 9th newtons per square meter. Under compression, if you're standing up and putting pressure on the bones that way, it's just 9 times 10 to the 9th newtons per meter squared. All right, but what we're after is 16 times 10 to the 9th newtons per meter squared. So we have Young's modulus is 16 times 10 to the 9th newtons per meter squared. Okay, all right. We have L naught. Now we can leave L naught in centimeters and get delta L in centimeters, or we can change L naught over to meters. Probably a good idea to change over to meters, just to make sure you don't mess things up in some way later on other problems where it does matter. Right? So L naught is 0.35 meters. So what we're after is delta L equals force divided by area, right? Times L naught divided by Young's modulus. That's what it works out to be. So this is 1764 newtons divided by 0.002 meters squared, right, times 0.35 meters divided by 16 times 10 to the 9th Newton per meter squared. Go in here and put a space right there. Okay. Now looking at units, right? Looking at units, the Newton here and Newton here, they cancel out. The meter squared here and the meter squares there, they cancel out. We're left with just meters. That's looking good because we're after a length and we're going to end up with just meters. So this is 1764 divided by 0.002 times 0.35 divided by 16. Okay, so in Excel you go 16E9. That's how you write 16 times 10 to the 9th in Excel. 16E9. Okay, and all of this works out to be 1.93 times 10 to the minus 5th meters. 1.93 times 10 to the minus 5th meters. And that is 19.3 micrometers or microns. 19.3 micrometers. A micron or a micrometer is 10 to the minus 6th meters. So the change in this is very small. Right? The change in the length of the bone is very small. For comparison, if we were talking about human hair, we would expect the width of a human hair to be somewhere around 17 to 180 microns. So width of a human hair, low end is 17 microns, upper end around 180 microns. So this change in length of the bone is roughly the same as a thin piece of hair, thin strand of hair. All right, that's it for problem 29.